Hello, my name is RD and we are going to solve this problem. The question is using nodal analysis, find V0 in the circuit of figure 3.57. Okay, the keyword is here, the nodal analysis. And how to do nodal analysis? Let's do step by step. The first step that we need to do is label all the nodes. Label all the nodes. And beside that, we also need to extract the information from the circuit. Okay. Maybe let's set the bottommost node here as our reference node or our ground. So this one will be our reference node or our ground. And what does that mean? That means that the voltage here is assumed to be 0. Good. Now, what can we get from here? We get this node here. Okay, and maybe let's name this node as node A. And what else that we can get from here? This is 5V0 from the ground. So this node here will be 5V0. This one will be a little bit tricky, right? And here we have V0 here. Okay, we will have V0 because this one will be V0 from the ground. Good. And now we have labeled all the nodes and we also extracted all the necessary information. And then the second step will be assume the current direction. Let's assume the current direction. Okay, let's see what can we get from here. Maybe let's assume this is going to the right and this is going down and this also going to the right. But if we assume this is going to the right, because this is a series resistance, this will goes up like this. Okay, it will be useful later. And then I think we need additional information here because we cannot calculate the current that pass through this 60-volt voltage source. But because it is in series with this 20 ohm, we can calculate via this current here. So we need the value of this node here. And this is 60 volt behind A, 60 volt under A. Why? Because the difference between this node and this node has to be 60. So we will have, this one will be VA minus 60. So this is not A, so let's just name the voltage here VA, like this. Okay, we have the first step and second step done. We need to do the most crucial step, which is do KCL. Do KCL for each node. Each node. Okay, let's do KCL. First thing that I need is KCL at VA. Let's do exactly that. Let's do KCL at node VA. What does KCL say? KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Good. And here, the only current that goes in is this one, right? And we need to calculate that using Ohm's law. And we can calculate that by using V0. V0 is where the current comes from. And then minus VA. VA is where the current goes to, here. And then because this is voltage and we need current, we divide by the resistance between them. So we'll have 6 ohm. Like this. Good. And then all the other currents are going out. So I need to calculate this, but I cannot calculate via this 60-volt voltage source. So I calculate via this resistor here. And that is VA minus 60, which is where the current comes from. And it goes to the ground. So I will have minus 0 here. And this is voltage. To get current, we need to divide by the resistance between them, which is 20. Good. And now we'll have this current here, and we can play similar game here. The current comes from VA, and then the current goes to 5V0. So we'll have minus 5V0, and then divided by the resistance between them. So I will have 20. Good. Now let's multiply both sides here, I think by 60. Why? Because that will cancel out all the denominator, right? 6 and 60 will cancel into 10, so we'll have 10V0 minus 10VA, and that will equal to 20 and 60 will cancel into 3, so I will have 3VA, and then minus 60 multiplied by 3, so I will have minus 180. And then we will have 20 and 60 also canceled into 3, so we'll have 3VA, and then we will have minus 15V0. Good. Now let's move this V0 to the left hand side, so I will have 25V0, and then I will have minus, what does that mean? We will have, yeah, minus 10, minus 3, and minus 3, minus 16. I think we'll have minus 16 VA. And all of that will equal to minus 180. I think nothing that we can do further from here. Let's save this as equation number 1. Okay? Because we have two variables, we need one more equation. Okay, and how to do that? Let's do another KCL, but this time at V0. Let's do that. Let's do KCL at node V0. KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, the only current that goes in is this one, and that current is 0 because it comes from the ground and it goes into V0. So we'll have 0 minus V0 divided by the resistance between them, which is 4. Good. And that will equal to, this is the current that goes out. I will have V0 minus VA divided by 6. Okay. Maybe let's multiply both sides here by 12. So we will have 4 and 12 canceled into 3. So we'll have minus 3V0. Okay. And then on the right hand side, 6 and 12 will cancel into 2. So I will have 2V0. 2V0 minus 2VA. Okay. And now we can move all this to the left hand side. So we'll have minus 5V0. And then plus 2VA. And that will equal to 0. And this is our second equation. Now we have two equations and two variables. This is equation number 1. And this is equation number 2. And I think the fastest way to calculate this is by using calculator. Let's do exactly that. Let's set up our calculator here as equation solver, which is this button here. And then equation solver is number 5. And two variables is number 1. And now let's plug the coefficient. So I will have 25. And then minus 16. And then minus 180. Right? This is the coefficient. 25 minus 16 and minus 180. So this is for the first equation. And then the second equation, we will have minus 5, and then 2, and then 0. Good. So we will have the value of the x, which is the V0 here. So we will have V0 is equal to 12 volt. And then VA will be the Y value, which is 30 volt. Okay, and what does the question ask? The question asks about V0, so we already get the value of V0, which is 12 volt, right? So we will have this one here as our final answer. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.